Hi, I'm Michael Paul, and I made a video of the use of a program that I wrote as an example of what I could do for another company if they would hire me. And I have my resume out on monster.com, but I forgot to mention this important stuff in the early part of the video so that people would know that before they got bored and stopped watching until later in the video when I did mention it. So I wanted to make a little preamble to put onto the video, and now we'll just get on to the video as it stands, and you can make up your mind whether or not you would want to go to monster.com and look up the resume of Michael Paul and see about having me do some programming for you. Thank you. Hi, I'm Michael Paul. I don't make videos. I usually just write programs and stuff, so this is just an attempt to show off a program that I wrote, and if the whole narrator thing doesn't sound good, well, it's just the way it is. I wrote this program in 2006 in response to a problem we had at work where a spreadsheet was being provided to tell us what data we needed to fix, but the way that it was oriented was not particularly helpful. A column was provided as the value that should be in the table, and a column was provided that was the correct value, and when the two were different, they weren't always different. They sometimes were the same, we just had to ignore them. When they were different, we were expected to put the correct value into the database. So I just kind of invented an idea for a scripting language to handle this. One of the things that came out of it is that the language development went really quickly once I resurrected an old idea of the first character in every line being the control. An exclamation point is basically a print statement. A pound sign is a conditional where if a value has been selected as being updated, it will turn this line, the PA, I hope you can make out the mouse cursor here. The PA points number equals T. Well, up here, if T is not the same as K, T became active. So basically it would go through here and say, well, should I use T? All right. Up here is U somewhere. U equals. U is a U equals means that if it had anything in it at all, that should be selected. K bar is another special rule for getting K activated, and I have all kinds of documentation here. The original email that I wrote describing the language is buried in this help thing somewhere. But basically, down here, here's the equals part. Using Z as an example, means a non-blank value in Z, activate Z. And then J bar is similar to J equals, but the entire section, oh, by the way, there are sections here that I'll explain in a moment. The entire section would not appear just because of a single thing like K here being ready to be activated. Sections were important because I needed a way to say that one chunk of the SQL was a thing. So there's a star here as this section. And then further down, another section starts. So everything is related to the sections. So what happens is that you get, excuse me a moment, you get the data, and it came in the form of a spreadsheet, but I have no spreadsheets left. I just have the comma-separated variable files, or CSVs. when the program first started, there was no support to actually read a spreadsheet, and so people had to save the spreadsheet as a CSV so that it would go into this program. So what would be nice here is to be able to see which column is which, but I'm pretty much stuck now with just having the data. And if I run the generator, it's really quick when there's not much to do. Basically, it created a set of SQL statements to conform to what was requested here. A bunch of updates. I thought I had a delete in here somewhere still, but I can try and find another example later if I feel it's appropriate. So anyway, the program only took a couple of weeks to get going. I mean, I had it generating stuff in a couple of weeks, but as soon as I got it working, people started doing things that I didn't anticipate. I mean, I spec'd it out according to what we told the users to do, and then the users decided to do what they wanted to do, including we told them to put a value into the U column for a Y for yes, I want to delete this row. Well, they decided to put N for no in there instead, and instead of just being able to say that column was blank, I had to go and add logic to actually say, well, is it this particular value, which lengthened the development cycle and did improve the program, but it wasn't exactly a great deal to all of a sudden have deletes showing up when they weren't supposed to be there, and you had to go through and make sure that temporarily you removed all the N's and just left the Y's so that it worked properly. So it was one of those things where coordination between what the users were doing and what the program was doing in response needed to be improved quite a bit, because to this day, many years later, it's still not particularly perfect. However, since I haven't worked in 4 years, and the last time I updated it at all was 2010, it's not like there's much goodness that you're going to find. So anyway, there are other examples of what the program will do really well, really fast. Here's a set of data that was used for QA load testing. I used to be a QA load tester too. And it just basically inserted values into the database to support a particular test. And we had a list of client IDs, which is the thing we referenced our clients by at work. There are 18,695 different clients, just because we needed a lot of data. And over here we have the SQL statements that would be built around those client names. It's just, client IDs, excuse me. And it just would take the A column and insert it into here. And down here, B stands for break. And the break is on A, and it's every 935 entries. We were inserting rollbacks and then commits. The rollback is important because you want to try and run the spoofy first, spoofy being a way to execute the SQL. Run it and then trash it so that you can tell whether or not it worked right. So every 935 it would do a commit, but before we were sure, we wanted to look for errors, there would be a rollback first and then the commit, so that it would be able to be graded and see whether or not everything was working, and then once it was working, you just commented out the rollback and you carried on. The commit's important because DB2, which is the database we were using, didn't actually like having a million inserts happen and then eventually a commit. It liked things to be more controlled, so only doing a certain number of inserts at a time was a good idea. And here's the exit section, which since a break would happen every 9:35, but you wouldn't know what was happening at the end, an X for exit section would do the same rollback and commit. Again, rollback would be removed once everything was done. So that's 18,000. I added this thing down here to make sure that I know how many lines are in each window. 18,000 different client IDs. There's a little indicator here of how it's going, just to make sure you knew that it wasn't just sitting there sleeping. This is an important thing for the old version of Windows XP. I traced through one time trying to figure out why a file that was over 1 million bytes was opening too slowly, and found that 2 spots inside the window opening code that Windows provided as part of the operating system, it posted a message and then just sat there and waited while something happened. God only knows what that something is. So when I found out that it was just going to sit there and be clocking while people were expecting it to open, I had this pop-up installed to make sure that people knew that it was a big file. It might just sit there for a while, and you should be patient. So once I say OK, it'll open the generated file, and I like that it's not responding. So anyway, it'll eventually open up. But, I hate getting partway through a demonstration and then having a general Windows doesn't want to cooperate thing go on. This is where people are probably laughing. So anyway, I think you're going to find part of this video edited out, because I'm just going to have to sit here and wait and figure out what's going on. Hang on. Okay, so here's the results of the file being opened. I hope you can appreciate the fact that, well, heck, let's try this again. All right, so here's the pop-up that I had to add in order to make sure people knew that the program was still working, even though a kind of what I consider a flaw in Windows is that a text file or a file that's just a plain text as opposed to a rich text doesn't open very quickly if it exceeds a certain size. It's like 1 million bytes. After that size, the operating system does something where 2 different spots in the code to open a window, it would post a message and then just sit there until it was done. No matter whatever it was doing, you had to wait for it. So I added this pop-up so that once a file was big enough to probably need to pause while being opened, this would warn the user that if they said OK, there would be a delay waiting for things to open up. So and it's not opening again. If you're paying attention to the clock down here, you'll notice that I've had to have a few pauses while recording. Windows 7 responds differently than Windows XP ever did with this program, including saying that the program is not responding at certain points, and I'll show you why. Here's another example of what I was using this program for. We had requirements for a lot of data for QA load testing, and to generate it, I set up a template here to take entries from this list of client IDs and put them into a bunch of insert statements here. It's just stuff that needed to be in the database so that the testing could happen. As part of doing all these inserts, it turned out that 935 inserts at a time was, a good amount to put in and not have issues with DB2 buffering. So this is a break statement. The break is on A, and it's every 935. A rollback and commit would be put in. Now, rollback is important so that once you run it, you can roll back the changes, look at the results to make sure that everything inserted correctly, and then if everything is fine, comment out the rollback, and then the commit would take care of making sure the inserts happen. Same thing down here at the end where there would be no break. It's like if there were 500 left. An X statement would take care of inserting at the very end the rollback and commit, and again, rollback would only be there until testing of the quality of your inserts would be over. So what I'm going to do, and you haven't seen these other ones, but what I'm going to do is generate this, and what's going to happen, down here there's the indicator of what's going on, and it's a little slower than it might have been in the first example because there's more data. This pop-up is telling people that the size of the output file has exceeded like 1 million bytes, and that's the point at which a flaw kicks in where the Windows still just sits there and clocks. I traced through one time and found 2 different spots where a message was posted during the window opening, and it just sits there and clocks away until whatever is happening in the background is done, and then carries on. So what's going to happen here is that when I hit OK, it's going to try and open up the file it just generated, and then we get not responding because that's what Windows 7 likes to do when a program is busy in a lock loop or whatever you want to call it. There is a lock loop going on. It's not my doing. It's the idea that the operating system to this day still wants to do something. Instead of just allocating memory and shoving the text into it, it's doing something else on top of that, and it's really annoying that it carries on. I never did a rich text version of this. It would have been at least something to do, but that may or may not have the same large file opening issues. Like I had to patch the code for opening a file to make sure that a 1 million byte file is actually acceptable. I think I might have gone for as much as 10 million maximum or something, hard-coded in where a lower value was actually coded before. I didn't like doing that, but when you got to do it, you got to do it. So what's going to happen here is eventually the file will be open and the program will be ready. A big file will take this long. It could be as much as a minute to open up. Meanwhile, everything that was happily ticking away when it wasn't in a lock loop is just sitting there frozen. And now it's done. It took almost 2 minutes, maybe more than 2 minutes to open up, but that's just the way it goes, especially when there are 4 million lines in the file. I'm not sure what the size is, but it's 4 million lines, so that isn't exactly small. So here's the output with each client ID in its place. Down here, we have, well, let me go back up and search for it. See, down here, there are the rollback and commit statements waiting to be used. when the spoofie is run. And then all I do at the end is either delete it or comment it out so that there would be no no rollback, and then the commit would just commit the data. And like I say, there's 4 million lines in this file, and it's 18,695 sets of inserts. So the generation goes fairly quickly. It's just if you're going to review the data, this program is not exactly the right thing to do. It's probably better to use a text editor that doesn't have that lag in opening files thing going on to review the data. But I wanted the tool to be able to do everything. It's just some of it doesn't do very well. So anyway, that's an example of just plain, insert something really quick. I have other examples, plenty of other examples. Here's one where the entire database can be dumped if you do a special query of the sysibm.syscolumns table. So what I was doing was I was getting very involved in that particular set of tables, the sysibm tables, and I built insert and copy statements, basically getters and setters, so that I would be able to get data from one version of the database with its copy of its own sysibm.syscolumns information, and insert them into another different version of the database, build its setter, and then modify whatever I needed to do by hand so that the getter from one database and the setter to another database were compatible, and then take care of that. Because sometimes you have different companies with different versions of the database, and you have to move data between them. There are aspects of this that are interesting. I'll show you in a sec. See how fast it works when it's a small output file. Oh no, that was a subtemplate, sorry. This is the get, and what happens here is that it does a select from the database you're trying to get from, and it does all kinds of things to make sure that it's a compatible to use in the setter stuff. Like the word space is a substitute for finding blanks in the data, because a blank is hard to take care of in terms of a general substitution, but the word space doesn't exist as a legitimate word, so it's okay to stick it into the final output. So what would happen is you would run this select. Columns that were blank would have the word space in them. Columns that ended up being null, because a dash is what showed up in the output, the word null would be inserted instead, making it more consistent to know what was going on. And the word null is a legitimate thing as opposed to space. So there's just so many things that it needed to do to make sure that when it pulled data into a text file, the data was ready to go from the text file back into another insert into another database. So it's one of those things that it came up as a gee whiz, if only this program could do that. And I said, all right, I might as well try and make it do that. That's how this program took 4 years, from 2006 to 2010. It grew quite a bit. I mean, it started out as a command line interface, and it had absolutely the bare minimum features for the longest time. Putting it inside of a Microsoft fundamental classes project turned out to be a huge increase in quality, because everything's in memory at one time, so you can just do memory related manipulations instead of doing anything just reading from a file. Let's go with the, we'll skip to the pièce de résistance, if you want to call it that. The Java stuff that I did. We were told that if we took all the Java courses that were available online, the train yourself kind of thing, we would be able to get jobs doing Java programming. Well, that didn't work out because there were, let's be frank here, there were cheaper programmers from elsewhere, offshore, that were more suited to being a profitable way to go. So they still ended up doing most of the Java stuff, and the rest of us either did what we were doing, which was important, but not particularly profitable to be put on to projects where it was important to keep the customer happy by being cheap. So I ended up kind of learning enough about Java to get dangerous at it, and then ended up being laid off. This is code to implement what I thought would be a nice substitute for I think it was called Harvest, way of generating a set of database access methods for a generic table. You could just have 25 tables, and they would get 25 methods of accessing the data in those tables. I decided to do it on my own. I did this all in Eclipse, and then genericized it to the point of being able to generate it. So I invented a class for a generic table and some stuff to go with it, the standard Java-related stuff that you tack on to make sure that everything is. I don't know if I still have the examples anywhere handy. Let me. Let's see here. Well, this is how it was going to work. Basically, there was a connection set up to get to the database, and then this particular example of the class is a policy tab table, and what it would do is select from policy tab where blah blah blah, and then it would as it pulled in values, the get next to get basically the first one at the top, it would print them and then roll back and do a get next until it ran out of data and then disconnect. This worked. I'm not sure what the somewhere out there there's a DB2 stuff package that includes the other junk that I had to put together to make this all completely working Java program. 4 years later, remembering all the details of Java programming is kind of difficult. C programming I've been doing for coming up on 30 years, so it's not like I need to remember an awful lot about C. It sticks very well, but Java was just a quick thing, and some of the details are missing now. So anyway, it took an awful lot of code to get this to work, and this is another thing that I had to put together. Basically, at certain spots there are chunks of code that are generated, and then those are substituted in here. Up at the top here, these are templates that are required to make the entire project. There's, I think it's like 20, 25 or something like that. And then each one of those templates has to be generated once you make a change. If you don't make changes, you can avoid regenerating everything. You can just turn off the refresh sub-templates. This is important when I was getting tired waiting for things to happen. And then down here, these are the references. Like a clear appears down here in the code somewhere. And then, here's clear. And the code that clear is supposed to be is from javaclear.subtable, SUBT. And so once you generate absolutely everything, it puts all of the inserts in, like get full key, min F2, and all the things that needed to be genericized. A good chunk of the stuff was standard. There's only a few things that don't appear everywhere. Like some tables had a particular column that did a particular job, some tables didn't, and so that had to be sorted out. But basically what happens here is it's going to generate, it's 26 total sub-templates, and they're all being generated. Again, they're small little things, but they're based on every table in the database, and the database had over 1,000 tables, so some of them are doing more work, some of them aren't. And then eventually, once it gets up to 26, it'll be ready to open up the final product. Now again, the final product isn't that huge compared to the other one, and it should open more quickly than the nurse questions version. But it's probably going to complain that it's too big. Oh, I also open the sub-templates for reference so that you can go in and look at them and see that they are what you wanted. Again, busy opening the sub-templates was important because otherwise you would just be clocking another feature of Windows. All right, so all of that stuff is happening now. It was generating while I was talking, and then again the output is very large, and we're going to try and get it to open. See if it beats the clocking out alert or not. Or not. No, it's fine. Well, it'll get, yeah, here we go. All right. So now we have a set of classes that would go in and get data from each of the tables. Some of them, I decided to have some. If you fill in a particular value into the target structure and then try and just get next, it would go in, see what you had filled in. That's why the clear was important. You clear it, you fill in like a client ID, and then you would go and get all of the related client IDs from that particular table. Let's see about class fields. As soon as we get back over to everything. I hope Windows 7 eventually gets better. All right, well, here's build policy table. Down here, policy ID is a key element, so you would put in policy ID, and then eventually you would be able to pull through all the values, like from the example. If you just, all right, well, this isn't the right example, but you would basically be able to do the get next based on policy ID being filled in, and you would be able to pull in all the values that were related to that. A huge flaw is that this is all dynamic SQL, and they're not particularly thrilled with dynamic SQL showing up in a is that wrong? Dynamic SQL showing up in a compiled program for use on a host is apparently bad. You are expected to use static SQL all the time so that there is no bind and rebind going on inside. I can understand why you want to be able to tell everybody that your program is the fastest thing in the universe and such, but dynamic SQL for some jobs seemed like an ideal thing to me. So I built this with what I had. I didn't have static available for the Eclipse that I was using. I had to use dynamic. This could probably be beaten into shape to use static instead, but I'm not sure the beating would be as flexible because, like I say, I like those. I like the ability to build a query and then say, go do it to get a job done inside of a program. I do not like the idea of having to have every single query that I'd ever want to do hard-coded in and dynamically bound so that it would be permanently, you have to recompile the program just to make, a minor change or something like that. So it's like, because I'm just a guy who programs instead of a real computer scientist, I guess I just don't get why some things have to be the way they are. So anyway, there are a whole bunch of this one had 1.5 million lines in it. It's not quite as big as the other one, but it still took a while to open. But basically, every time you get to the point of the class existing, you have another whole entire class. Now, the support files, the ones that define this class, all these classes and stuff like that, exists somewhere. I don't know where anymore. I'm lucky that I still have the program to generate with, because sorted math trees. But whatever this package was, it included the stuff that was defined to support the classes. See if I can still find anything else. I'm not seeing them anymore. Oh, by the way, just for sport, this is the select statement that gets you the information out of your sysibm.sys columns to basically be able to spell out exactly what a database looks like. I wrote this once upon a time. A customer had our older product installed, which had a local database and then a host database, and they had DB2 Connect so that you could get at both at the same time if you wanted. So we downloaded a copy of the database onto each local machine for all the local work, and then once you wanted to do the final processing, you submitted it to be uploaded to the host, where all the processing would happen on the host with the same database. But sometimes, every once in a while, a flaw would happen where the copy of the database on the local machine was not up to date. So they wanted to be able to check to make sure that the database was correct on the local. So I wrote this query to pull all the details of the database, and then I saved that to a file, and then a query was done against the host database and saved to a file, and then the OS2 version of diff, the Unix program, but ported to OS2, would go and compare the two files, and any differences would be flagged, So you'd be able to go, oh, wait, this database is not the same. So you would run the database migrator again, and then hopefully you would get a good copy, and you'd be all set for the processing. I think part of the death of that version of our system was the lack of continuity between getting a database onto the machine and having it happen correctly every time. The internet would have been a much better way to implement the move, but this was not an internet kind of thing at the time. Product we're using now, the one that this stuff makes inserts for, is an internet one. So times change, programs change. So anyway, this is assuming somebody is still watching this video at this point and hasn't tuned out completely. So, but anyway, like I said, the Cascade. This is my best program ever. If you want to put a grading on, my grading on it is it's my masterpiece. Because it does what it does very well. It does lots of things that, well, here. This was another one of those things that I came up with once upon a time, and I needed a way to implement this because the idea was good, but nobody ever actually used it. There was a suggestion box thing once upon a time, where you would submit ideas for how to improve things. And one of the things that was going wrong with our programming at the time was that people were hard-coding the length of character variables into the programs, and then if the database changed one way or the other, like a column for a last name went from 15 characters to 20 characters, or even worse, 20 characters to 15 characters, the programs were all going to be stuck at whatever value was the last one in there, unless somebody went through with a fine-tooth comb and found every single possible change that there needed to be made and made them all. It is such a wonderful thing, especially with OS/2 not being the world's most stable operating system. Well, part of its problem was faulty compilers that IBM required you to pay for to replace. But part of it was also just a general things went weird. So I came up with the idea that we would make a set of defines for the length of every single character, long var, and varchar variable in the system, and it would be updated every time that the database would change, and so a new header file would be provided to make sure that everybody was on the same page with all the same lengths. And what would happen? Well, the data queried out to show what the details of each table was, and this would this is a simple. It's going to H being the column that is the table name. It would spit out if H was filled in. It would spit out H, showing where you were, and the if E, the column type, was char, it would define H as the table guy, and A and then F. HA would be the table name and the column name, and F would be the length. So generate, and for every single table and column name in the database, there is a define now that shows what would be the correct value to hold. Well, these would be C strings because that's what we were doing. So 12 plus 1 would always be available if you used the table name and then it's underscore the table name underscore column name all the way through, all 8,991 defines existed. All you had to do was, instead of using 12 or 13 as the value, you would use this as the value. It worked for everything. I think the limit at the time, they've increased the limit for the names of tables and columns since this came around. But at the time, 33 character defined name worked inside of the C compiler, so you would just use it. It might be ungainly, but it also was very highly documentary. It documented what you were using that particular variable for. So if somebody was confused as to why a variable existed, finding out that it was defined as the effective type code for this particular table, that would mean, now I know what this variable is doing. So it had multiple uses. And because people liked the idea enough to say, yeah, that was pretty good, I got $250 for the idea, but this was never implemented. So now I had a way to implement it, but this came along way too late for C code to be of interest. It could possibly be a Java thing too, the idea that Java might need something related to this for a particular aspect of it, but since Java uses mostly dynamic stuff, it's not like it's going to all be all that helpful. So it's a great idea that never went anywhere, which is pretty much my career. So anyway, this video exists to show this thing off as a complement to my resume, which is out there on monster.com and some other places. The huge flaw in the resume is that I never graduated from college. So I'm not particularly high on anybody's list to hire just because I don't have a college degree. I mean, I'm a computer programmer, not a computer scientist. Computer programming is more of an art than computer science is. So I don't want to call myself an artist. It's just that it's easier to go that route in explaining the difference between a computer programmer and a computer scientist than anything else that I can come up with. It's just that I'm a okay artist. One of those self-evaluation things where you're supposed to evaluate yourself. My official self-evaluation is highly competent with occasional flashes of brilliance. This is one of my flashes of brilliance. Didn't help keeping the job, but it did make me feel that I had a decent thing that it could have. I was thinking it could have turned into a product all on its own. Just be something that a small company could sell. Put enough security on it so people couldn't copy it and use it, indiscriminately. That kind of stuff. It could have been a product that could be sold. It was built in a company that if the product being sold isn't worth $1 million a copy, it wasn't exactly something that was going to be nursed into being a real product. So it just didn't work out. So anyway, here's something else to landing zone. This is another thing that was done for C programming. The idea was that a structure to hold the contents of each read from the database was important. So there are these structures that are, the chars. There's enough room to hold a char plus the trailing null. A date needs 11 characters. Timestamps need 27 characters. And it indicates which column number it is. And here, way at the end here, this is standard C comment. So it's column 1. The key information is marked here. whether or not it can be null, the type, and then the length. So this was a way to generate quickly a landing zone. That's why it's called landing zone template. Landing zone for the data from the table. It's just another one of those things that it seemed like the ability. Oh, bar chars needed to have the length and the text separate, because that's the way a bar char was supposed to work. I think we had lots of one way or the other, whether a bar char actually required this length, a spot to put the length, or whether it didn't. But I'm not sure that we also didn't have bugs because we forgot to provide this every single time. So as part of this generator, I provided it, and it like I say, it didn't get much use or anything like that, but it existed as a thing to have in case it ever came up. The program was never finished. It does what it does very well in most cases. Sometimes it crashes, but I blame Windows. I mean, if I can run it 12 times in a row and it works fine, and that 13th time it doesn't, well, I went through and profiled the heck out of it and ran it under debugs and watched to make sure that memory was not being left allocated when the program shut down. And it still crashes occasionally, so I blame Windows. That's pretty much the universal thing to do, is to blame Windows and then hope that nobody ever challenges you to prove it. So it's got things that could be improved or changed or whatever. But the trick is that I don't own it. I'm not supposed to even have this one because I don't work there anymore. I just have it because I did not want to let this go. This is, being my masterpiece, I wanted to be able to say, yes, I could still show it to somebody if it ever came up and then somebody said they want to see what it was that I was doing for a living. Here's another interesting example. We had data from the testing, SMF data, the QA load testing, but this might have been the host-related testing that I never really got into. But we had this big blob of data, and we needed to make it more readable. So the idea was to take it and put it out into reformatting it. Basically, what you're doing here is you're spitting back out all of the columns worth of information, and then down here we have some of the Excel-related stuff that was put out as part of doing a summary. And here we have, like, the B3 column times the F3 column would be here. The Q3 divided by Q15 would be here. Q15, I guess, might have been that one. I'm not sure. So anyway, and then down here at the bottom, the sum of Q2 through Q14, which was actually dynamic, because there's a little doohickey here where they're counted as you process them, so that you would know that you started at Q2 in here, being the first real line of data, and then as it ran the generation, it would count all of the lines being generated, and the T, greater than T is that count. Back here, greater than C is like I think it's like C for current row, the number of the current row being processed. T being the total rows processed, and S being something. Oh, here we go. Current line, current CSV line number, summary, total CSV line numbers plus 1. Total CSV line numbers. +1 must have been important to do something, like maybe include something else. I don't know. A now timestamp, number of lines written. There were things that needed to be added as time went on, and these are some of the things. So anyway, it had great potential. People were using it for their other projects, but mostly they were using it for swabbing data, just like I started with swabbing data. The fact that it could do all kinds of programming-related generations, well, that just wasn't the way things were supposed to work anymore. You know, Java was the miracle that was going to save everything and all that other blah blah stuff. There is, if I hate to get annoying here, but C, the programming language C, has everything anybody would ever want to be able to do, as long as you have the right add-ons to make it work. I mean, if you buy the right package for this job and package for that job, you can do whatever you want. I think Java tends to be a wonderful idea for marketing, where you would tell people that they could write it once and run it anywhere. But since I would go to a grocery store and see that the Java-based checkout register had crashed again, there's just something wrong with the concept of relying on Java for, constant use. If you take your time and build a C program and check to make sure that everything you've allocated has been deallocated when you're done with it, it usually doesn't just up and crash on its own. So there's not much I can say except I would really like to become a C programmer again somewhere. It's just that that lack of a computer science degree is in the way, and I'm hoping that somebody would, if you're still watching this all this late in the video, get a hold of me and let me know if you would want me to try and program something for you. This is about as good as I've gotten so far. I could get something better if I was given the opportunity. So, thanks anyway. Bye. Testing, 1, 2, 3. Okay. One thing that I want to tack on the end. I finished the production, and I said, oh, well, wait a minute. There's one concession that I made to the internet back in the day. Basically, there was a kind of a need to make sure that a person who was, doing whatever they were doing with, that's kind of slow, doing whatever they were doing with, the product, you generated something, blah, blah, blah. But if you needed to go out to the internet and look for stuff, I decided to go and stick a Internet Explorer window inside so that you could be doing whatever you're doing. Let's set. What the heck? Here's a thing, and you generate that thing. Not particularly short, and we should have picked a different one. Sometimes fast, sometimes slow. Oh, I think it's because there was a multitude of rules here. There's 1,700 lines of, if the C column is this, insert that kind of stuff going on. So it's not particularly quick. Let's say you were done with it, and you had what you were doing, and you said, oh, wait a minute, I need to look up what that means. At least you'd be able to do it inside the program without having to go elsewhere. All it does is just open an Internet Explorer window in here, but at least it's in here as opposed to being, another item down on the tray for you to be, flipping back and forth between. And then you can just, it'd be in your cascade of windows, so you just look there and then flip back here, and and so it was a more of a novelty item than a useful tool, but somebody might say that it's a useful thing anyway. So what the heck? Anyway, that's pretty much all the stuff that I can think of to talk about. I mean, there was way more programming stuff to talk about that, but people don't usually talk about programming a lot. They just do it. And this just being like the language the manual for the language. It's not, but it's in there, and all the stuff that I could be showing, I'm not showing because there's just way too much. And I think this video is going to end up being almost an hour anyway, so we'll just have to see what happens. And if you manage to see this part, you were very dedicated to watching the video. You might be my sister and maybe one other person, but that's the way it goes. All right. Thank you very much. Bye.